morning. We're starting section 3.2, identifying linear functions. And you just had a few minutes to discuss what a linear function is, the differences between a linear function and a nonlinear function. Okay, what are the, what's the main definition for a linear function? The most obvious thing. It is a line. Good. It is a straight line. By the way, line by definition is straight, so it is a, I'll just put it here. It is a straight line. Okay, what else is it? I heard someone say it. Non-vertical. Because if it's a vertical line, it does not have a slope. So vertical lines do not. Non-vertical. What else? It has a rate of change. Good, a constant rate of change. Which is the slope. So let's put that all together. The slope, which we consider the m. It is also the change of y over the change of x. If you had an awesome middle school teacher, they should have also told you that it is delta y over delta x. And it's called the rate of change. Okay, nonlinear function is not a straight line. And it does not have a constant rate of change. Okay, if you're watching my video, make sure you pause it and you take notes. We are on page 112 of your textbook. So if you'd like to follow along, page 112, we're going to be doing the examples and the monitoring progress. Okay, here's example 1. Take a look at this picture. Is this a linear or nonlinear function? It is a nonlinear. Why is it nonlinear? It's not a straight line. Okay, not a straight line. This one, linear or nonlinear? Linear. So it's pretty good. Okay, let's move on. Now we have tables. Okay, the first one was a graph. Now we have tables. And we have to check to see if it has a constant rate of change. The way that you check if it has a constant rate of change is if the change in the y's over the change in the x's are the same. So let's look here at the y's. From here to here, what happens? Subtract 6. From here to here, what happens? Subtract 6. From here to here, what happens? Subtract 6. Okay, from here to here, what happens? Add 3. From here to here, what happens? Add 3. From here to here, what happens? Okay, so the change in y looks like it's constant. It is -6 over +3. So it means that this slope is -2. So I'm going to take a moment to tell you something about slope. Slope. So two little graphs here. Change the color. Let's use blue. Uphill, downhill. Okay, which one is negative slope? Downhill. So this one is negative slope. That means that this one has a positive slope. Okay, so if you're watching my video, I'm going to want you to pause it, and I'm going to want you to do B all on your own. Okay, we're now on page 113 in your textbook. These are the monitoring progresses, 1 or 2. So, number 1, linear or nonlinear? Linear, yes. Good job, you guys. Linear or nonlinear? Nonlinear, awesome. Okay, let's move on to 3 and 4. Let's see. Constant rate of change. Let's do the change in the y's first. And I'm doing this so that you can also learn how to find the slope. So how do I get from 3 to 5? Add 2. 5 to 7. Add 2. 7 to 9. Awesome. So my change in my y is going to be 2. Now let's look at my change in my x's. 0 to 1? Add 1. 1 to 2? Add 1. 2 to 3? Add 1. So that is over 1. So that means my slope is going to be 2. Okay, is this linear equation, linear function, going uphill or downhill? Uphill because it's positive. Good. And let's do 4. Change of y. 16 to 8. Subtract 8. Oh. 8 to 4. Ah, I can stop right away. So, notice they're not the same. This one is going to be subtract 2, not the same. The answer is non-linear.